Okay, so let's run the birthday paradox. The birthday paradox shows us that in a group of n people, the odds that 2 of them have matching birthdays is surprisingly large. This program does a Monte Carlo simulation, that is, repeated random simulations, to explore this concept. It's not actually a paradox, it's just a surprising result. How many birthdays shall I generate? So let's generate 45 birthdays. Enter. Here are 45 birthdays. And it shows the birthdays, but not the year, just the month and date and day. In this simulation, multiple people have a birthday on June the 12th. So in these 45 birthdays, there's more than one person with a birthday on June the 12th. Were I to run this program again and put in 45 or 100 or 50, whatever number, the birthdays are randomly generated. Therefore, only sometimes will multiple people have the same birthday date in the list that gets generated. Sometimes this line here will read in this simulation, no one has a birthday on the same date. So next, the program generates 45 random birthdays 100,000 times. Okay, so it's doing it again and again and again and again, 45 times based on 45 from user input. It generates 45 random birthdays 100,000 times. So let's press enter to make that happen. So it gets down to 100,000 simulations run. Out of 100,000 simulations of 45 people, there was a matching birthday in that group 94,061 times. This means that in a group of 45 people, this means that 45 people have a 94.06% chance of having a matching birthday in their group. So a group of 45 people, if you were to put them together in a real room, in a real situation, in reality, and you ran it 100,000 times in this simulation, there'll be a 94.06% chance of a group of 45 people having the same birthday. And so, that's probably more than you would think. So now I'm going to explore the code behind this program, this simulation. Okay, so here's the code for the birthday paradox. We have here a couple of functions, and we have a print statement that the user will see. Some tuples where we're setting up a tuple for the months, a while loop, and generation of the birthday. And you can see here that this particular code, I'll just find an example. It doesn't use, here we go, let's go Control F, format. So there's no use of F strings in this particular code, but I'll probably change that. So later on in this video, you won't see it. using the old school way, you'll see I'll change that to properly change it to F strings. So, but at this stage in the video, just notice that it's about 114 lines of code as it currently sits, and I might reduce that by a few lines by using F strings. But there's the code. So the first thing really for me is to create a doc string at the top that kind of describes what the code does. So the birthday paradox, also called the birthday problem, is a surprisingly high. I'll just make this a little bit bigger for a second. F11. Yep. So the birthday paradox, also called the birthday problem, is the surprisingly high probability that two people will have the same birthday, even in a small group of people. In a group of 70 people, there's a 99.9% chance of two people having a matching birthday. Even in a group as small as 23 people, there's a 50% chance of a matching birthday. So this program performs several probability experiments to determine the percentages for groups of different sizes. So that's based on user input. We call these types of experiments, in which we conduct multiple random trials to understand the likely outcomes, Monte Carlo experiments. So I'm going to now look at the first function here. It's called getBirthdays, and it has only one parameter, that's number of birthdays. So the point of this function is to return a list of it returns a list of number random date objects for birthdays. Returns a list of returns a list of random date objects. Returns a list of random date objects. Yeah, for birthdays. So it's using a for loop here, and it's going to be putting into a list called birthdays. So for each iterator, for each birthday, and I haven't used birthday there because the word birthday gets used later on, so just use the colloquial I. For each iterator in range number of birthdays, so there's going to be user input later on that will define number of birthdays as an integer. So for each iteration in the number of birthdays, so it'll stop at the number of birthdays, the start of year, so it says the year is unimportant for our simulation as long as all birthdays have the same year. So this, as you saw before, this program won't deal with years and matching years. It just deals with the actual day and month matching, not the year matching. That would throw this up here off a bit. So the year is unimportant for our simulation as long as all birthdays have the same year. So in here we're saying the start of year equals, and we've imported the datetime library, and we're applying then we're using the date function, or the date method to a module to set the I'll just quickly get the lines showing up again. So line 23 here, we're importing so this line 23, and up here I'm just explaining that we're importing date time, and that it's asking the second, after the second comma, that's the month, and the last one's the day. So in here, you can put anything in the year. It doesn't really matter. In here, it's just 2001 because it's going to not, as I mentioned, excluding the year. So it doesn't matter what you put in there as long as it's a 4-digit year. And here it gets a little bit more interesting. It says that now you want to get a random day into the year. So these are the days. Well, that's the month, that's the day. So here it's saying random number of days equals the date time library, import the time delta. And so time delta is a method used to calculate the differences, or the difference in dates. The output is a date. So for example, if I run this code here, and we'll see down here it says from date time import time delta using current time. So the initial time for now equals the date time dot date. So I'm calling it today. That I'll just say the 15th, which was yesterday. Here it's the 16th, but I'm just using yesterday. So print out the initial date. So the initial date is year 2022, February the 15th. And so that's what's been printed via this, attaching that to initial time for now. So we print the initial date out and turn that into a string, initial time for now, and it comes out with initial date here. And then we can calculate the future date in whatever we want to put in. So in this case, this example is put in 2 years time from the 15th. So future date after 2 years equals initial time for now plus the time delta, right? And so it's got days equals 730 days. So it's going to add 730 days to the 15th of February. And so what day will that be? Well, we'll print the future date after 2 years, and that'll be the 15th of the 2nd, 2024, right? So that can be useful because sometimes some months have 28 days in or whatnot. But anyway, that's just something there, I suppose. And what's interesting about this line here in the code is the way it generates. Just put it back like this. The way it generates the time delta, right? So in here, in this example, to explain date time library and the time delta module is it's specified the number of days, but we want something random, so it's accessing that's why we have the random library here, because we want that to be a randomly generated integer between 0 and 364. So that's pretty neat how it's done that. So that's a randomly generated time delta. And so then finally we can create a new variable, the birthday variable, which is going to be the start of the year, which you got up here, plus the random number of days, which we've just got here. And then we're appending that birthday. We're appending that birthday to the birthdays list, which is here. And then finally it returns birthdays. So that's a neat little function, I reckon. Haven't used anyone else's modules yet, other than the manual module. And I just haven't used anyone because it makes my own. Total anal about it. Shitty, 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 shitty. Now, the last one. Okay, so we finished with get birthdays function. I'm going to move on to the get match function. It has one parameter, birthdays. And the point of get match function is to return the date of a birthday that occurs more than once in the birthdays list. So the birthdays list was up here in the other function, and these functions are called later on further down in the code. So here's birthdays called again, and so that's the purpose of it. In line 35 we have, if the length of birthdays equals the length of the set of birthdays, then return none, because all birthdays are unique. Now what is a set? What is a set? A set is the items in a set list are unordered. Right, so it is a list. Birthdays is a list, and because up here it's a list, and when you put the set, when I put the set function in front of it, well, we know that a list is unordered. The items in a set list are unordered, so it will, well, the items in the list are in the order in which they're listed in. If I put set in front of it, it will then unorder it randomly. So the items in a set list are unordered, so it will appear in random order. For example, x equals set, and then I put this list in, or this tuple in, and then I run this code. Right, we're looking at this part here. When I run this code, what will happen each time I run it, notice how it changes: banana, apple, cherry, apple. It's randomly resorting the tuple, and that's what the set function does. Back to get match function. So that means that if it's true, then all birthdays are unique, so return none. Then the other way is to compare each birthday to every other birthday, so it will return a matching birthday. So that's the part where we get it saying, in this simulation, multiple people have a birthday on June 12. Well, this function plays into that. So at line 39, we have a for loop for A and birthday A. For each A and birthday A in birthdays, which is a list, then for each B in birthdays B in birthdays, and I'll get to enumerate in a sec, in birthdays, item A plus 1, go on to the next one, next item, and keep on going to the end of the list. That's what this means. So starting at A plus 1 and then right through to the end of the list, because it's a for loop. then if birthday A and birthday B are equal to one another, if that's true, return birthday A. Because it's returning a matching birthday. What enumerate does? What does enumerate mean? The enumerate function returns both the index of each item and the value of each item as I loop through a tuple or a list. So here we have birthdays is in a list. It's going to be called later on in the code further down, but it's a list type. Then enumerate will associate an index with each item and the value of each item as it gets looped through. Right? I hope that makes sense. Here's an example of it, a little mini example of it. So here, enumerate can work with a list or a tuple. And in this example here, I've created a tuple. So x equals apple, banana, cherry. Y enumerates through x. And what will it print out? Well, I'll run it again. It prints out the index 0 is associated now with apple, and 1 associated with banana, 2 associated with cherry, and so on. It's kind of like a dictionary, but not quite. It's just doing exactly that. It's returning both the index of each item and the value of each item as I loop through a tuple or a list. Because you know that the first element in a list, or the first item in a list, it starts from 0, 1, 2, 3, 4, 5, 6, and so on. All this is doing is putting inserting the index to each item in the list, so we know where we can where that item is in the list. So if you want to do something like this, if you want to call that list or print that particular item in the list, we know where the index of that item is. So I could go like print, I could say something like print, I could create I could presumably go print, no, I won't do it in this example, but I could print out banana, given that I know where its place is, which in this instance is 1. So I'll risk it and 1 banana. You see, it prints out banana. If I want to put in 0, it'll print out apple. So that's what's going on there. I hope that makes sense, but if not, have a little bit more of a closer look at it. Okay, so we've finished the get birthdays function, and we've finished going through the get match function. So now we're up to the main part, I guess, of the program, where we tie it all together. And the first thing that's done is to print the description of the program. So that's what the user sees. So the user sees that here. That's what the user sees. And then we go on to setting up a tuple of month names in the correct order: January, February, March, and so on. And it's a tuple because we don't want to change the order, and we don't want that order to be changed, later on in any way. We want that to stay the same, and it may even be indexed later on in the code so that happens. When I say indexed, I actually mean making use of the enumerate function, which will index it. But we'll have a look at that a bit later and see if that's the case. So that explains. So we've got the months tuple there, and now it's entering a while loop, while true. So it's broken down here. And what this indent of code does is it's going to keep on asking the user for input until the user enters a valid amount. So there's requirements then. Print how many birthdays shall I generate? Maximum 100. So that's the first question. How many birthdays shall I generate? Maximum 100. If you enter more than that, it'll just keep on asking you, how many birthdays shall I generate? If you enter something less than 0, it won't move on. And if you enter a decimal, it won't move on. So it's got to be something between presumably 1 and 100. If I put in 0 here, interesting, let's see what it does. It'll still ask. So you've really got to enter something between 1 and 100. If I enter 6, then it will go on. So how does it filter out that? Well, the first thing it's doing, I can see here, is it's labeling user input as a response, and then it's got an if statement saying if the response dot is decimal. Now, what is decimal? I'll get into that in a sec. But if the response is between 0 and 9, and it is not a decimal, I'll explain that in a sec. But that's what is decimal is. Actually, I'll explain it now. So is decimal returns a string between 0 and 9. It can also check that the input given is a digit 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and nothing else, like no decimal places. So I can demonstrate that here. And the way you can do that is by putting a U in front, because is decimal relates to, I think it's ASCII code, or Unicode rather, Unicode. So if this is 2009, that's a string. Right? What's the Unicode for that? Well, it doesn't really matter. It's something like U15321, or can you even make Unicode for it? But it would have a Unicode, I guess. But let's print and see if this string here, this 2009, if it's a decimal, right? So I'm going to run it, and it comes up with false down here. It's a bit counterintuitive, this is decimal function, because you're expecting to see something like 3.503, but as you'll see in line 41, I want to know what the Unicode is for 234443434, right? I don't know that. I don't want to know that. I want to know whether this constitutes a string that's a decimal string, right? And it actually comes up with true. So the first time I saw this is decimal, I was thinking, okay, it has to be like 3.56. It has to have a decimal place in it, but it's actually not. It just means 0 to 9. And that's why when you print out this string, it will say true, because I think it has something to do with Unicode, and you guys can look up that yourselves a bit. I'm not going to go into that here, but my point is that if the response is consists of zeros and nines and doesn't have a decimal place in it, because if we put decimal places in, like I've tried here, it'll just ask it again. So that's a good thing. That means it's working. So if the response is not a decimal, right, and the response is has 0 as being less than the integer, so it's almost doubling up here, then it's less than the integer response, because it's got to be, they've got to convert whatever the response is to an integer if they can, and that response is less than or equal to 100, then the number of B days, which is used later on, equals that response, whatever the user's response was. And just making sure that it's integer again, I guess. And provided that happens, then we'll break out of the while loop because the user has entered a valid amount. Okay, so the next part of the code is this section of code here. And that deals with generating and displaying the birthdays. So when we generate and display the birthdays, that's this part here. And that's what we're dealing with. So it's this print statement here is evidence that the code written by Mr. Swigart, or L. Swigart, is using the old school way of displaying strings or text on the screen. It's just string formatting as opposed to F strings. So I'm not going to change this code to F strings, but I could just put an F in front of there and put number of days in braces. But I'll just stick with the majority of his code without changing too much. I'm just noting to you that here are 45 random birthdays, or here are 45 birthdays. It's just using the old string formatting way of text printing. So to get into it, we have a new variable. It's called birthdays. Now it's a global variable because it's outside any indent. We have seen it, I think, further up. Yeah, we saw it here. This is where birthdays was a local variable. It was only going to apply to the get match function. But now we've got birthdays as a global variable. And birthdays is the label for, or birthdays calls the get birthdays function, which we've already made. And get birthdays has a parameter. That parameter is number of birthdays, and it's filling in that parameter, number of birthdays, with num b days, which we've made just before then, which we get from depending on the user's input between 1 and 100. And so that successfully calls the get birthdays function and associates it with the global variable now birthdays. Now we have a for loop, and so for each iterator and birthday, in the enumerate, which is indexed, as we've mentioned before. It's just indexed 0, 1, 2, 3, the birthdays. If the iterator does not equal 0, then display a comma for each birthday after the first birthday. So it's printing the birthday and it's adding a comma and a space to the end of each birthday after he's put first down, but after the preceding birthday. So this doesn't use F strings. Another way to write this would have been to use F strings, but what that does is it starts to get it nicely formatted with this happening. But there's a bit more to it. So it prints that at the end of, that's what the end means. What does end mean? End is used to place a space after the displayed string instead of a new line. There's a bit more to it, and we'll get onto that. But then it's inside the same for loop. We've now gone outside this if statement. It says month name, so a new variable, and that variable equals months, which we've put up here. So months is the tuple, and then it's gonna pull the index. So just one. It's not going to pull all the months out, January to December. It's just only going to pull one of them out, because we have here it's going to index it. That's why I've got the square brackets. And how's it going to index it? Well, it's going to go to the birthday, which is in birthdays, and then we've associated birthday. It's linked into the datetime library. So birthday dot month -1. So I'll explain what the dot month is soon, but -1 means we're getting it from the end, right? The last iteration. Now the dot month means this. So dot month is an attribute. So we'll just go over to here and you'll see datetime is a class, right? So datetime, datetime, that is a class. It's an object in Python. And date dot month, right? So anything with dot month in it, like I'm using here. So birthday dot month, date dot month, birthday dot month, with just the same thing, is one. So in Python, and date dot month is one of the datetime's class attributes. Others include date year, date minimum, date maximum, and so dot month is always between 1 and 12. So that's gonna pull something that's between 1 and 12. It's gonna pick the last one from it. So this may still be a bit confusing, but hopefully I've gone some way in explaining that. Now we have a new variable. It's called date text, and because it's the old version of string formatting here, we don't have an F string. What he's done is just put a string to put two braces in there, and he's formatting that first brace with month name, which we've just made up here. So
and then the birthday, the birthday, right? So .day is also from the date time class. It's also a attribute of the date time class. And so this one here is going into that brace. And so that's why I see that's what's happening here, January, and then 30, April 24. That's what I can see happening there. And I prints date text and then puts a space at the end of it, which we've also done there, and we've also done there. I didn't really pick that up at this point, that there's two of them, but there is two of them. At any rate, it prints out the right thing. I don't know if you need two of them. Maybe if you are looking at this and you can see why you'll need two, let me know. I can see why this bit would need one. And if the iteration does not equal 0, display a comma for each birthday after the first birthday. And then it does it again there. All right, well, I don't know if you need it twice, but we'll just leave it at that for that one. Okay, so that's that one done.
Okay, so the next part is line 80 here. Determine if there are two birthdays that match. There's a new match variable, and that variable is calling the getMatch function, which is up here. And it's using birthdays to fill in the parameter that's required. And now we want to display the results. So it's going to print in this simulation, because we're up to here now, in this simulation, and it will split out. It will print something different here, depending on if people have birthdays that match or not. So in this simulation, at the end of the string, he wants to write something at the end of that string. That's what the end is for. In this simulation, if match, and match is calling, is linked, is associated with the getMatch function. If match does not equal none, in other words, if there is a match, then get the month, the last month that matches from the months variable, which is here, and link that into month name. Let's call that month name. And then, so we've got that there. And then the actual text that the user sees, this part here, is dealt with the date text variable, which is just a string, a formatted string. So month name is going into the first braces here, and then it's associating the day attribute to match, to the match variable, which is linked in, which calls the get match function, which is associated with the datetime library. So that's why we can put .day there and .month, because .day and .month are attributes of the datetime module. So if the match does not equal none, so if there is a match, print multiple people have a birthday on whatever that date is, because date text now. Whatever that date is, that's what that will come up with. So multiple people have a birthday on June the 12th. So somewhere in this list, there's more than one June 12th. There's a June 12th there, I notice, and there'll be another June 12th somewhere in there as well. Now, if there are no matching birthdays, then it's just else. Print there are no matching birthdays. Okay, so next up is running through the 100,000 simulations. So generating number of birthdays, generating 45 or whatever the user input was, because number of birthdays is linked up to the user's input. Generating 45 random birthdays 100,000 times is what it should say. There we go. Generating 45 random birthdays 100,000 times. Press enter to begin. That's an input. So any input could do, but press enter, it'll go on to the next line. Let's run another 100,000 simulations. So now it's really about to run 100,000 simulations. So here we have a variable we've called simMatch, and it starts at 0, and then it's a for loop here, which means that it's going to continue until it gets to the end of, it's going to keep on iterating until it gets to the end of a range, and that range is 100,000. And then at every 10,000 simulations, it's going to report on the progress at every 10,000 simulations. So 10,000 simulations, 20,000 simulations, 30, and on. But it's not really going to report how many, well, it's not going to report how many matches there are per 10,000 simulation. It's really, what it's really doing is, if you didn't have this, and I'll explain this part further, but if in a second, but in a little while, but if you didn't have this here and your computer was slow, it would say to the user, let's run another 100,000 simulations. and then you might have to wait, I don't know, 20 seconds or 10 seconds, depending on how fast your computer is, before it actually prints out this. So the real reason for this bit here is just to let the user know that the computer is actually working, because if it wasn't there, it'll just be like 10 or 20 seconds, and the user might think there's something wrong with the program and close it. So we don't want that to happen. We want the user to know that the program is running and the computer is thinking. So that's why you have this 10,000 increment. And it does that because, well, it starts off, as I mentioned, with for each iteration in range 100,000. If the iterator, it's really saying when the iterators gets to 10,000, and if you were to divide 10,000 by 10,000, it'll equal 1. But we're using the modular operator here, which means that when you divide 10,000 by 10,000 via the modulator operator, it returns a remainder, and there is no remainder when 10,000 divided by 10,000, it equals 0. So provided this is true, then it will print 10,000 simulations run. $10,000 simulations run, 20,000 simulations run, and so on. So at 20,000, if you went 20,000 divided by 10,000 modular. If you went 20,000 divided by 10,000, the remainder of that would be 0. If you went 30,000 divided by 10,000, 0. 40,000, 50,000, and so on. Every time you divide that increment by 10,000, the remainder is always going to be 0. And so I think that's how the computer will go 10,000, 20,000, 30,000. That's why it knows how to go via 10,000 increments until it gets to 100,000, in which case it stops. Now the for loop's continuing. We've exited the if statement here, control statement, and we've made a new variable called birthdays, which calls getBirthdays, the getBirthdays function. But the parameter for the getBirthdays function, which is up here, is something called numBdays, so number of birthdays. It's different from number of birthdays. It's called numBdays. And as I think I may have mentioned before, numBdays, that parameter comes from user input, because number of birthdays is the response, which is user input. It's converted to an integer. So that successfully calls the getBirthdays function and associates it with a new variable called birthdays. So if the getMatch function, right, which is here, and birthdays, which we've got from up here, if that actually is anything but nothing, then the simulation match equals the simulation match plus 1. So then the for loop will keep on running. Simulation match will go to 1, and then it will run through this again, and if it's anything but nothing, that will go to 2. Sorry, this bit here will go from 1 to 2, then it'll go from 2 to 3, 3 to 4, and it'll keep on going from 3 to 4 to 3 to 5. There might not be that many, but, well, there will be. There's a lot. If over 100,000, there's going to be a lot of matches. And so it'll keep on going until there really is none. Or until 100,000 simulations are run, obviously. Right, so that's that part. Great. Oh, yeah. Okay, great. Up to the last kind of section of code here. This part. And this is the part where the program will display the simulation results. And that's this part here. We're creating an object, a variable called probability, and here he's using the sim match object, which will increase to however many times there are matching birthdays per 100,000 simulations. So, for example, I will calculate this here to show myself what's happening mathematically. It needs to produce a percentage. It needs to produce some sort of percentage. So I'll just deal with this part here. And I think, without going too deep into it, say there were 51,250 sim matches. So say that went to 51,250. That's how I'm currently interpreting this code. I'll divide it by the 100,000 simulations, and that'll equal 0.51, which as a percentage is, you just times it by 100, is 51.25%. And so that's this part here. Now the 2 at the end is a derivative of the rounding function. So it'll round this calculation to 2 decimal places. If I made that 3, it'll round it to 3 decimal places. I think if I left it blank, it will just round it to no decimal places, to a whole number. So if I say x equals round 3.12345, and I put 2 like that, and I print out x, and I run that, it'll round it to 2 decimal places. So that deals with that. And so now, I mean, this could be done a better way rather than printing it out like this. But he's done it this way. I guess it's kind of an old school way. I would use an F string to write it out. Anyway, he's got out of 100,000 simulation of number of birthdays, which we've already talked about upstairs, further up the code. It's based on user input. So that 45 people. In this example here, we've got 45. Out of 100,000 simulation for 45 people, there was a matching birthday in that group. Sim match number of times, which is this one here. So it could be 51,000 times. This means that the number of days people have a sort of number of days. This means that 45 people have a probability, in this case 94.06, have a probability, right, which we calculated this way. And then it's a percentage chance of having matching birthdays in that group. That's probably more than you would think. Now, I'm guessing that there's a little bit more to this calculation than I may have explained just then, but hopefully that makes sense. And so that rounds out this code. On to the next project.